Okay, hello everyone. In this occasion, I will present you about what my team provide for this Arango Hackathon, building the next generation of agentic app with GraphTech and NVIDIA to graph. Okay, next slide. For the first, let me introduce my team. My team consists of two persons. For the first is myself. I'm Faris Akorni. I'm data analyst and data engineer. And for the second is Jafar Aziz, is a software engineer. Participating in this hackathon offers a valuable platform to integrate our expertise and dedication to environmental initiative. Next, the background of the project starts with the statement of what figure and scientists fired by this type. From Antonio Guterres, our addiction to fossil fuels is tend to frankincense monster, the effort on our planet. And the scientists say that the collapse of our civilization and the extinction of much of the natural world is on the horizon. From this insight, our team in France became to green living is on you. We aim to harness data to empower individuals and communities towards sustainable practice. Okay, next slide. Then data and business problem. I will explain you about data and business problem. Slide. In our project, we integrate three primary datasets and construct a comprehensive environmental knowledge graph. For the first is Sentinel Copernicus Static Imagery. This dataset provides high resolution or observation data, enabling us to assess environment factors such as land use, vegetation cover, and pollution level. The next is OpenStreetMap data containing the object of the renewable energy, EV charging station, and other facility for green living and environmental sustainable. And the last is F1 register. This is the news article data that allowing us to extract and analyze news related to environment, event, and trends. Next slide. The business problem we can address is environmental monitoring, providing up-to-date information about the pollution level, green space, and renewable energy, and then infrastructure accessibility like EV charging station, public transport station, and renewable generator, and also recycling facilities to encourage their utilization. And then information dissemination, aggregating and analyzing news related to environmental issues to keep communities informed and engaged. Next slide. And then now we enter the processing graph, data processing to graph because our data is geospatial and article data. We use format, we utilize format like Parquet and GeoPackage to store geospatial data efficiently, ensuring quick access and reduce storage overhead. And then by performing spatial join, we integrated various geospatial data sets, aligning features based on spatial relationship to enrich our data. And for use data relationship, we use LM generated knowledge graph with name some entity recognition or NAIR techniques to extract entities such as organization, location, and environment from news article. Next. And this is the data or the notebook of our data ranking and conversion. This is processing data about the energy for battery, for geothermal energy, hydro energy, tidal energy, wave energy, and wind energy. Also, we have data about solar power generator, and this data is we do conversion from the format of GeoJSON to Parquet and GeoPackage, so the data can quickly accessible and efficient to process. Next slide. And the next is the spatial join process. We process the GeoPackage data to spatial join with the administrative boundary like city or country, so we can connect the uh, database to the graph of the database of energy, the database of population grid, the gaseous pollutant grid to the city and the country. And then next is LLM generated knowledge graph. We use LLM to generate our knowledge from the news article, like the entity, the type, and the location. After that, the entity, the type, and the location join with the graph previously I mentioned, so the data can be integrated to a single graph. Next slide. Then the data integrated to single graph we process to the graph in network X. We use network X the graph or directional graph for convert the data to the graph. We can see that the data from the energy or power generator, we connect the data into the location and then the object type. Then the data from the article and news, also we connect the data to the city, to the country, and to the entity type. So we can have a database that is integrate the facility like the charging station and then public transportation. We can connect all the energy power generator and the data of the news entity and the data of administrative boundary like city or county. Next. Then we persist the graph. We use network X ArangoDB package or NXADB to persist the graph into ArangoDB. You can see that from the notebook, we have a green leafing graph at our database in ArangoDB. This graph is built from the network X graph have called we have built in the previous section. Okay, next. And this is the graph visualization. This is the graph visualization. We use the ArangoDB web for graph visualization for ease to use and good performance. So we can see that the standard of the graph is administrative boundary, such as city or country, and the uh, circle of the graph in the outside is the entity of object, entity of article, and the entity of grid. Because we use satellite imagery, we have great data about the population, the gas pollutant, and etc. And next, the agentic app. From the data in ArangoDB, that is the form of knowledge graph, we build an agentic app with this structure. From the start, we determine location from the processing query, and from the determined location, we found that the geolocation that is contained by the query is found in database or is not found in database. For the location that is found in database, we generate the ATL, the execute ATL with the network X, and attach geospatial data, and then we generate the response. For the location that is not in database, we do forward decoding the geolocation, and we generate ATL, we execute ATL with network X, and attach the geospatial data. And last, for no geolocation provided by query, we just generate SQL, we execute ATL with a network X, and we generate the response. So the response consists of two elements. The number one is the geospatial data, and the other is the text generated or insight generated by the LLM from the generated data. Okay, next. This is the for us to use the gain ATL. The gain ATL, this is the function to generate the ATL from the natural language, and then the tool of text to network X algorithm to text. This is the tool for execute the ATL and then the generate insight from the data. And we have the main function query graph. This is the function to execute the natural language to generate the final response. And we implement the agentic app with LangChain and LangGraph. This is the implementation of our agentic app. And you can see the output at the bottom of the right. Okay, next. This application demo will be uh, presented by my teammate Jafar. Please.
Okay, thank you. We will demo our application. Here is our we create simple web application as a prototype project to prompt and visualize the data that is query from our backend from query database. Let's try we use a simple queries such as find EV charging station in Berlin. We will find all EV charging station in Berlin. We will query from our DB and our LLM. After query, we will given uh, map and point where a EV charging station is located in Berlin. And this is query from our DB that previous explained. Let's try with another query. Uh, we will query in another place. Let's find highest population location in Hessen, and we will result about where is the population is highest in Hessen. Mm, we can try another query, but the time is up.
Okay, thank you, Aziz. The time is up. So maybe one query about the gaseous pollution. You can show to us about the channel name.
Uh, okay, we want to see highest CO level in Bayern. We will query that. Uh, in Bayern, we can see some place that have a higher CO level. We will query. We have
Okay, thank you. Okay, thank you. We have see the highest CO pollution in Bayern, so in that place, that location. Okay, great. Thank you, Aziz. From this presentation, I say thank you about your attention and see you.